Hello, this is Scott at MechSoft. In this video, I'm going to give you a more extensive overview of the 3-axis milling capabilities found in Alibre CAM. Just a brief note as I begin this demo. Some of the functionality and operations that are shown in this video may only be available in the higher product configurations that we offer. Please check with our sales department before making any purchase decisions so that we can help you determine the correct product configuration that will suit your needs. This is the demonstration part, and I will create a sequence of machining operations that are commonly used to rough, semi-finish, and finish parts like this, which require full 3-axis milling. So to get started, I'll go to the Add-ons tab, choose Alibre CAM, and then select the Machining Operations browser, which comes up on the left of your screen. At this point, I have already defined the stock box or workpiece shape around this part and have defined the position of the work 0 or program 0. Likewise, I have predefined the cutters that I will need to machine the part, and with each cutter, I've specified the tool number, tool length compensation register, feeds and speeds, and coolant type for each cutter. First, I would like to rough off all the excess material using a flat end mill. I will go to the machining browser and choose 3-axis, then horizontal roughing. This operation will automatically cut all the geometry on the screen, so I don't need to select any geometry here. For the tool, I'm going to use the flat end mill. Feeds and speeds, make sure I load those from the tool. Cut parameters, I want to leave 0.6 millimeter stock on all surfaces for finishing. Do climb cutting, and the step over will be calculated as 50% of the tool diameter. For the cut levels, I want the depth of cut in Z to be calculated as 30% of the tool diameter. And I want to make sure that I clear the flats because I do have flats on this particular part, and I do want to leave that amount of stock on those flats. At that point, I'm ready to generate the operation. I'll simulate this path. In the next operation, I'm going to semi-finish the part by knocking down these steps that were formed by the roughing cutter. So I'll go to 3-axis, and this time I'll choose the horizontal re-roughing operation. Again, in this operation, I don't need to select any geometry. I'm going to use a 12 millimeter ball mill and set the cut levels to be 20% of the tool's diameter and generate the operation. And there is the resultant tool path. Now I'll simulate this path, and you'll see that the step over is much finer and that the cutting is localized only to the material that remains after the horizontal roughing. One other function that I can point out that is very nice under simulation control is that at any moment I can pause this and tell the system to complete the material removal to the end of the path without displaying the tool. In just a few moments, you will see the final results. And there it is. That will save you some time. The next operation will be a finishing operation that will do parallel cuts across the entire face of the part. So I will select parallel finishing. Again, no need to select any geometry. I'm going to use the 12 millimeter ball mill and set the step over to be 20% of the cutter diameter and generate this operation. And there is the tool path for the parallel finishing. I will simulate this path, and remember that this is a finishing path and it will clean up a lot of the scallops on the front section of the part. And to save time again, I'll pause it and run to the end, and there are the finished results. Now with the next finishing operation, I'd like to clean up these scallops that are on the steeper sections of the part. To do that, I'll go to the 3-axis option and choose Steeps Z Finishing. Here again, all geometry will be considered. I'll use the same tool as the parallel finishing, and under Cut Parameters, I'm going to set the operation to cut anything steeper than 40 degrees. Now I'll generate the operation and simulate the path. In the next operation, I'm going to use a flat end mill to face off all these flat surfaces, including the parting line. So I'll go to 3-axis and choose Flats Machining. The system automatically determines the horizontal flat regions, so I don't need to select any geometry. I'm going to use the flat end mill, set the cut parameters to make sure I have 0 stock, and I'm ready to generate the operation. And there's the resultant toolpath. The final operation will be pencil tracing. I'll use a small ball cutter, and the system will find all bitangencies on the part and run the cutter along those areas. I'll go to 3-axis and find pencil tracing. Again, no reason to select any geometry here, it's all considered. I'm going to use a 6mm ball mill, and I want to make sure that the stock is set to 0, and I'm ready to generate the operation. And there's the toolpath for the pencil tracing. I'll simulate the toolpath of this final pencil tracing operation, and this will conclude the demonstration on 3-axis milling. Bear in mind that this is only 6 of the operations of the available 19 under 3-axis milling. There's a lot more to take a look at. Thank you.